Get what Menalaus and Ceva look like. Okay.
Okay.
So you missed out on Ceva, right?
Didn't I miss out on Ceva?
Yeah, but you must have seen it at some point.
Yeah.
So Ceva's theorem was like if you have like a triangle, yeah, and you drew like these lines from the vertices to the sides, they're concurrent if they have like this ratio, like this A, B, C.
Oh, actually,
So it's like this is like X, Y, Z or something, right? So you just go around. So it's like AY divided by YB times BX divided by CX, XC times CZ divided by AZ, yeah, equals 1. And then it's concurrent.
yeah.
So remember what Menalaus is? That's the one we remember because we've done that recently.
Yeah.
Menalaus, you also have a triangle, yeah?
Yeah.
Okay, but it's like the sides extended, yeah?
Yes.
Where, how far are they extended to? Well, somewhere, right?
Yeah.
So this is A, B, C, yeah? This is like X, Y, Z, yeah?
Yeah, it should just be the same.
Oh, okay, so it's not so obvious
Is it not?
because the
Like the ratios of it was the same. But actually,
well, it's weird because what happens to the ratios?
well, it's not.
You don't know, like
Yeah,
if you have lengths, it's not a projective theorem, yeah. So if you have like, so the thing was ours was purely about lines and intersections, so it was easy to dual, right? So the problem is here we don't know how to dual statements like AY on YB equals 1, yeah. We don't know how to take the dual of that statement, yeah, because like these lengths become
Points.
yeah, we don't have lengths.
Yeah.
See what I'm saying? But maybe we can just look at the conclusions or something, yeah?
You can see
Maybe we can say the diagrams are dual or something. Okay, so this is collinear, yeah?
Yeah.
So that's like saying they're concurrent.
Yeah.
So X, Y, and Z give you lines, yeah? Okay, so what do you get? So you get a line that goes through. So the line Y, yeah. Let's show line Y. This is the line Y.
Has points A and B on it.
So it passes through the point. See, like the thing is, the line Y passes through the points that correspond to the lines that pass through Y. Yeah. So like the line AY, yeah. So AY is a line, yeah. That turns into a point, yeah. That point would lie on Y somewhere, yeah. That makes sense. Okay. But in the same line, they're the same point.
Oh wait. Yeah.
Mr. Trivial. Yeah. Okay. So then we have another line for X, yeah?
Yeah.
So
The open card.
X is a line, yeah? Okay.
And then I
Does it intersect the line at Y?
Wait. Yeah.
So it does, but it has the same. So there's a common point of intersection here, yeah? So that's this line, yeah?
Yeah.
So that's XZ, YZ, yeah? XY, yeah? They're the same point. Okay. And so this is the line Z, yeah? Yeah? Okay. This is the line Z. Okay. What other lines? What kind of lines pass through? Okay, so a line passing through. So there's another line that passes through AY, right? It's the one for A, yeah?
Yeah.
And the line for A also passes through the point for AX. Yeah?
Yeah.
And AX, the point, lies on the line X. Yeah? So it's like AX could be here, yeah? And this line here, right,
Yeah.
is
A.
A, yeah?
This is getting very confusing.
Should I change colors?
Uh, yeah,
Actually, that could have been a different color to begin with. That could have been the Revelation triangle colors.
Ah, yes, red.
I went out and bought some whiteboard markers.
Or rainbow colors. Hooray.
Thank you for your contribution.
Hooray.
So from now on, you must follow online. Alright, so A is that, yeah? Okay, what about B, yeah? So the line for B passes through the point for AX, yeah?
Yeah.
And the point for, wait a minute.
A-Y. Like something.
What are we doing now?
Yeah.
The line for B, right?
Yeah.
Okay, so the line for B passes through the point CZ and AY, yeah? Okay.
Yeah, but
CZ.
AY is just BY. So that means yeah.
Yeah, so where's CZ? CZ is a line, right?
Mm-hmm. It's a dot.
CZ is a dot, right? So CZ is a dot that lies on the line X.
Line.
Wait,
what? Isn't it on the line Z?
So it should be on the line Z and the line X.
Well, then they're just all in the middle.
Oh, okay, no. It should lie. How do we come up to this conclusion? So AY lies on Y. Wait, so CZ lies on Z and C, right? CZ has to lie on Z. The line for Z.
Yeah.
So it lies on somewhere here, yeah? See?
Okay.
Yeah? It lies on the line B and the line for Z, yeah?
Oh yeah, and then you can make like
And the line for C.
Oh, it does actually.
Yeah. So
Wow, that's really.
this is what I was going for. Wait, what am I connecting it to again?
C, Z and AY. Yeah, that's right.
Yeah?
That's the line C.
So this is the line B, yeah?
Wait, what? Oh, yeah. Same thing. Yeah, and then the last line is C.
Oh.
Like CZ and AX.
CZ. Okay, so the last line is C, yeah?
Yeah.
So it passes through the points CZ, yeah?
Yeah,
And AX,
yes.
yeah? Isn't that awesome?
And it looks exactly like the other one, except with extra lines. Whoa.
Yeah, so I guess in principle you didn't really miss out on Cephal's theorem.
Hooray.
Yeah, but that's all in the chapter 1. It's actually all on video.
Oh.
So.
Oh, okay.
Yeah, and a lot of the times what happens is like, it's not the topics that are important, you know what I'm saying? Because if you imagine, like, I never learned these topics, but I can just learn them as I'm reading it, right? Because I spend the time doing similar or harder difficulty stuff. So it's the maths maturity that allows you to progress, yeah? So you could miss all the topics, but you could just be working on sort of hard problems and other hard topics. But when you come to it, it's easy, you know? Yeah, there's this kind of unsaid thing in the culture was like, no one's actually read a maths book. It's like no one actually, because every time you set out to read a maths book, it's like a topic that you really want to learn, but it's usually too hard for you.
Wow.
So like when you try to read it, you just basically never, like you can try as hard as you can, but you always never get to the end.
Oh.
Okay? And then, but what happens like a few years later or something? You pick up the same book.
Yeah.
But at any point in the book, you could flip to it and understand everything
Yeah.
without ever reading it. It's kind of weird, huh?
What's
Yeah.
the point of maths books then?
Huh?
Why do people make maths books then?
Well, the book that you're struggling on is helping you with the book that you've already skipped.
Oh.
So if you never have the next one, the one you'll never actually come back
Oh, so you
and
have
look at the
zero
book and
points.
say that's easy, yeah.
Oh.
You're just like, oh, it's still hard because I never made any progress in
It
those
was
years.
memorable.
Oh, that's pretty cool, huh?
Yeah.
So they're duals to each other. If only we knew something about the length. Oh, that's pretty cool.